Hello there. Today we'll be doing another advanced graph problem, another interesting, um, let's say, algorithm. So cheapest flights with k-stops. In this particular problem, it's a little different from network delay time, but it's very similar as well. So in this particular problem, we're looking at let's get the shortest path. Let's get the shortest path. Let's get the minimum cost path, but in k turns. So in k stops. So that's the limitation here. We can't just use Dijkstra's like we did in network delay time. We need to find a way to create a breadth first search that moves about our graph in k turns and see if what's the cheapest price, or if it's not possible. So the way to do that is that for every turn, we're gonna update our, it's kind of like dynamic programming, it seems, but it's not. It's called what's his name? Shoot. I don't remember the formula. What was Bellman and Ford? Bellman and Ford, right? So the Bellman and Ford item is that what we're gonna do is that we're gonna update the price for every for k turns, and at every update we're gonna update the items that have prices that are not that are currently possible, that are not infinite, and once we get to those turns, we will update the movement. So here's what I mean. So here we see some examples here: 0, 1, 2, and 3. And so I guess the minimum cost, the way to get there is 1, 2, and 400 to get to 3. Destination is 3. We're starting from 1, so it's 300 if we go 1, 2, and 3. Why is it 700? Well, it's because of 100 plus 600, and we have only one stop. So we start from 0. So we have one stop. So it must be 700. So what I mean by that is, so for the first turn, we're gonna update our items. Let's say 0, 1, 2, and 3. And everything starts at well, of course 0, 0, and this starts at let's say infinite, and let's try to get through from 0 to 1. So we get from 0 to 1 using our let's say all our flights, and we go through that, and we go 0 to 1. That's 100 to get to 1, and then we try to get to 2. That's not possible because it's currently infinite. Well, we can't get from 1 to 2 because it's one is well, 1 is not infinite, but so that means we need a temporary item to hold our current prices, so that we don't accidentally move over to our new pricing, because if we did, this would be 200 and it would be 400 instead of 700. So what we're going to do here is set this to 100, and we're going to check this price up here to see if we can make the jump from 1 to 2, and the question answer is no, because this is infinite, and we can't. Infinite plus 100 is 100 infinite, which is way too much. So that's not possible. Okay, so with that, we moved on to the third one, 2 to 0. Can we get from 2 to 0? And the answer is no. And then let's see, from 1 to 3. Can we get from 1 to 3? Well, no. And can we get from 2 to 3? And the answer is no. So with the next turn, we reset this item to be 100, and we reset this item to be, with a copy of that. And we try 0 to 1, of course that's 100, same, and then 1 to 2. We can do that now because it was 100. Now it's 200 to 2. So we set that at the temp here. So it's 200 to 2, and we get to 3. 3 is 600. 600 plus 100 right here, 1 and 3, and that's gonna be 700 at 3. and that's 2 turns, and we're done. We're out of range at this point, and so we return 700. If otherwise we have k equals 0, 0 stops. That means that's impossible to get to 3, and this will stay as infinite, and we'll return -1. And that's our program. So let's get it. So we're gonna set our prices to equal to float of infinite items times, items that are infinite, the flight, and we're gonna set the first flight prices to at source to equal to 0. So for I in range of k plus 1, we're gonna set the temp price equal to prices. So we're gonna make that temporary item. And then now we're gonna do our source, destination, and price in flights. So we're gonna do this for every single flight, every single time. So S equals source, D equals destination, and P equals price. With that, if P equals float of the infinite, then we're gonna continue like we said in our example earlier. Otherwise, we're gonna set our temp price of destination to equal to the minimum between the prices of the source plus the price of going to the location and the current price of the destination. And so with that, we set prices equals temp price afterwards, so that we reset it. So exactly as we have suggested. So we're going to return prices destination if only if prices destination does not equal our float infinite, and else we're going to return -1. So let's run the code. Looks like there's an issue here. I'm guessing that we have to use double and a single quotation does not work. Let's run it. Indentation. I see. Run code. Temp prices. A typo. Great. Now let's submit and let's see. All right, not too bad. And that's Bellman and Ford in getting the cheapest price in K turns. Thank you very much. If you learned something today, what that is that to use a temp to hold each particular state and updating the states each time to get the lowest possible price for those number of turns. And if you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one. Thank you. Bye.